Welcome everybody to today's notes, which is going to be 9.4 parametric equations. So first I'm going to introduce to you is what parametric equations are. So first off, we have this equation right here. It's just something that we're used to. This is a Cartesian equation. This is when we just have variables of just x and y, and we know how to graph stuff like that. But then down here, we're going to get two equations, an x equals and a y equals, and these are parametric equations. What's different about the parametric equations is, yes, there are two equations compared to the Cartesian one where there's just one equation, but we have a third variable t here which represents time, which actually really matters. So for example, if we're ever just trying to graph like y equals, I don't know, x minus 1 squared, okay? If I go to graph that, it's going to look something like this. Okay, we should know how to graph that. So, but now if I go into parametric, let's say that I want x to equal t, y to equal t minus 1 squared, and let's say I want t to be from 0, I don't know, to 2. So in order to graph this one, I'll do this in a different color. What you do is you start at t equals 0. So when t is 0, well, what is the x value? The x value is also at 0. And what's the y value? The y value is at 1. So I would just start right here. And when t is 1, x is 1, and y is 0. And then when t is 2, x is 2, which is going to be over here, and then y is 1. So it looks just like this. So a line segment. So parametrics just give us, or not, it's not a line segment, it's just a segment of a curve. So that's what parametric equations does, is it gives us just segments and not these arrows right here that we would get in the other equations that we're familiar to. Okay? So a parametric equation allows you to determine the position and object of any time. And the variable t is the parameter. Okay? So we're going to go ahead and just practice sketching here. I know I just did it really quick above, but to sketch these, what you want to do is make a little bit of a table. So you want to have a t, make this a little bit thicker here. You want a t, you want an x, and you want a y. So t is negative 2. We just pick all the integers that are in between. Okay, so when t is negative 2, what is x? I'm going to plug it into right here. So x is negative 2. And what is y? Y is right here. Well, I'm going to get negative 2 times negative 2, which is, you guessed it, 4. And I'm just going to do these for all of these. So now that I have my table, I'm really just going to go ahead and start graphing these guys right here. Okay? So I'm going to go negative 2 up 4. I'm going to go negative 1, 2. Oh, I can't graph. Here it is. 0, 0. 1, negative 2, and then 2, negative 4. And kablamo. There is our first parametric equation graph that we have done. All right. So now that you get the idea, why don't you go ahead and give number 2 a try. Please pause it, and then when you're ready, hit play, and I will work this out for you. Okay, so same idea here. We're going to do a chart for this. We're going to have t, x, and y. So we're going to use t from negative 2 all the way until 3. And I plug this into here for x. It's a little bit more complicated. It's going to be kind of like a weird curve. But I'm going to get 0, plug it into t now. I'm going to get -1, -3, -0.5, -4, 0, -3, 1/2, 0, 1, 5, and 3/2. I know I did that kind of fast, but all I did was just plug in the x's into here, the y's into here. So what does this graph look like? Well, I'm going to start at 0, -1, then -3, -1/2, -4, 0, -3/2, 0, 1, and then 5 is 3/2. Okay? And I'm just going to connect those dots. Now you have to make sure you connect the dots in the correct order. So I started here to there, to there, to there, to there, to there. And that is our lovely parametric equation. Okay, now limiting the parameter. This is going to change this back into what we're used to, which is a y equals equation. Okay, so limiting the parameter is getting it back to a y equals equation. All right, so what you're going to do here is you usually want to try to solve for t and substitute. So which equation here between x and y is easier to solve for t? Very good. It's going to be this one right here, the y. So it's going to be t equals 2y. So you're going to go in and plug that into there. So x equals not t, but 2y, all squared minus 4. And then we're going to simplify and solve for y. So I'm going to simplify here. So x equals 4y squared minus 4. We have to get the y by itself here. So we're going to get x plus 4 equals 4y squared. Divide by 4, so x plus 4 all over 4 equals y squared. Y is almost by itself, so you have to take the square root. Anytime you take the square root of a squared, it's going to give you a plus or minus. So we're going to go ahead and do that right here. So plus or minus square root of x plus 4 all over 4, and that's going to equal y. Okay, so this equation right here is the same thing as this one right here. Well, these two combined. Okay? Why don't you go ahead and look at 4 and try to do 4 on your own. Go and pause the video and hit play when you are ready. Okay, so now I'm looking at these two. I don't know which one's necessarily easier, but I do see just one t variable here on the x. So that's probably easier to solve for. So let's go ahead and solve for x here. So I'm going to get square root of t plus 1 equals 1 over x. This is just me using two. I just skipped a step right there. I'm going to get t plus 1 equals 1 over x squared. And then t is equal to 1 over x squared minus 1. Okay, I'm going to take this and I'm going to plug it back into y. So let's go ahead and do that. So I'm going to get y equals, what's nice about this way is I already have the y by itself. So this is super nice. I don't need to do much rearranging after I am done here. So I'm going to get 1 over x squared minus 1 all over 1 over x squared minus 1 plus 1. So as you can see here, these parentheses are just plugged in for these t's. Okay. I'm doing a little bit of simplification here, not much, but it's going to be 1 over x squared minus 1 all over, well, these are going to cancel out, 1 over x squared. Okay, so let's go ahead and make this look nice here. So I'm going to multiply the top and bottom by x squared. Perfectly legal. Okay, because I'm multiplying the top of the fraction, bottom of the fraction by the same thing. Why did I pick x squared, you must be thinking? Well, I see this denominator is x squared. So if I multiply by the x squared, it's going to get rid of any fractions inside those fractions. So let's do it. So y is equal to x squared over x squared minus x squared all over x squared over x squared, which simplifies to 1 minus x squared all over 1, which is just y equals 1 minus x squared. And that's it. Go ahead and give 5 a try. Pause the video, you get the idea, right? Okay, so when we get this all by itself, we're going to get t to equal 1 over x squared. Plug that into there. Y equals 2 times 1 over x squared squared, which is going to give us 2 over x to the 4th. And what's the domain of this function here in 5? Well, our only restriction is our denominator cannot equal 0. So it just means x cannot equal 0. So that is our domain restriction there for number 5. Okay, so we're going to sketch this curve by limiting the parameter. Now I'm just giving you a heads up. Almost all of these problems look the same with the sines and cosines. So don't just think I'm just doing magic here and you need to figure out magic yourself. All of these problems, as you're kind of looking down, have a sine and a cosine, and we can talk about what we need to do for those. And they all have the same strategy, okay? So the key here is we need to think of an equation that we know that involves sine and cosine. So this is really the only equation I know, and it's my favorite equation, is going to be sine squared theta plus cosine squared theta equals 1. I know this is true, so I'm going to use this actually for all of these problems moving forward because it has a cosine and a sine. So what I really need to do is I need to solve for cosine and sine. So what does cosine equal? Well, it's x over 2. What does sine equal? Well, that's going to be y over 2. So plugging this in, we're going to get sine squared, which is going to be y over 2 squared, plus cosine squared, which is x over 2 squared equals 1, which is y squared over 4 plus x squared over 4 equals 1. This is actually an equation of a circle because these numbers are the same on the bottom here. So I'm going to multiply everything by 4 and I get y squared plus x squared equals 4. We usually like to put x's in front. It's because we're math people, it's what we do. So there is your equation. And this is an equation of a circle with a radius of, not 4, but 2. Okay, so it's going to be a circle. And draw your best circle that you can. And I guess that's my best. Okay? Same idea for 8. You want to solve for the sine and the cosine because, again, you want to plug into this sine squared theta plus cosine squared theta equation. So what we're going to do here is solve for sine and cosine. So what does cosine equal? Equals x over 5. What does sine equal? It's y over 3. So y over 3 squared plus x over 5 squared equals 1. I'm going to just rearrange this so the x is in front. So I'm going to get x squared over 25 plus y squared over 9 equals 1. And that should look like very good, an ellipse. What kind of ellipse? It's going to be horizontal. Why? Because the x value is larger. So we're going to go out 5 in each direction. We're centered at 0 here, and we're going to go up and down 3. And we're going to go ahead and sketch this the best that we can. why don't you go ahead and try number 9 on your own. It's very similar to 8. You should get an ellipse, so go ahead and try it out. Pause it, and we'll get back. Okay, so cosine of theta here is equal to x minus 1 over 3. Sine of theta here is equal to y plus 2 over 4. So when I do my sine squared plus cosine squared equals 1, I'm going to get y plus 2 all over 4. It's going to get squared plus x minus 1 over 3. It's all squared. A little bit of rearranging here. We're going to get x minus 1 squared all over 9 plus y plus 2 squared all over 16 equals 1, which is an ellipse. Okay, centered at it looks like it's going to be 1, negative 2. So go down to 1, negative 2. There's my center point. In the x direction, I'm going each way 3, and in the y direction, going each way 4. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. It's off the paper. Deal with it. And here we go. This is, I can't count. It should be right there, not right there. Okay, and there's our lovely ellipse. Questions? Good, I didn't think we had any questions. Okay, so finding parametric equations for a graph using, well, we have this, using the following parameters. Okay, so this one's pretty simple. This one just says that x is equal to t. Well, since x is equal to t, y is equal to 4 times x, correct? But not x anymore. It's going to be t minus 3. So that one is actually a pretty simple, just write it down here again so we have it all together. It's a pretty simple substitution, okay? This one right here, let's solve for x again. We're going to get x to equal, what is it, 2 minus t? So y is going to equal 4 times, not x, but 2 minus t minus 3, which that will simplify to, it looks like 5 minus 4t, and x we already said is 2 minus t, so this is the parametric equation for those parameters. Alright, and our time is almost coming up to an end. That's so sad. But these are super fun, so do not worry. So we have motion problems. So these formulas, don't worry, calculus students will be able to at some point get these formulas and solve for them, but you're pre-calculus, so you just need to memorize them. You don't need to know how or why right now these equations work this way. They just do. That's all I'm going to tell you for right now, because you do not have any calculus background. Okay? So x is going to be our horizontal projectile, and y is going to be our vertical projectile. Okay? Just take note right here, g, we're going to use it as negative 32 because it looks like we're doing everything in feet per second. So it's just going to be negative 32. All right, so Zoe kicked a soccer ball with initial velocity of 45 feet per second at an angle of 32 degrees to the horizontal. After 0.06 seconds, how far has the ball traveled horizontally and vertically? So what we need to do is we need to solve for these equations. So I have a v in each of these equations. Okay, the v is a vector, by the way. It's the magnitude of the vector. You have the theta value and you have the time. So what is the velocity here? It is 45. So it's going to get plugged in right there and right there. The theta we said was 32. And the time is 0.6. So x is going to equal, that v value is 45. Cosine of 32 degrees. Okay, all this times my time, which is 0.6. So you get out your handy dandy calculator. Cannot show one on here, so I'll just pretend that I typed that in. And that's what we should get. And you do the same thing for y. You plug everything in. So again, the velocity is 45. Sine of 32 degrees times 0.6 plus half of our gravity, which is pulling us down, 32, and then t squared, like that. And then you can plug that into your handy dandy calculator and get 8.547 feet. Okay. I like 12 because it's not just plugging in. You got to do a little bit of thinking here. So if you want to try it out just to see how you do, go ahead. It's a little bit different. It's not just plugging in. We give you some different variables, but go ahead and give it a try. Okay, so let's go ahead and go through this. So we got a toy rocket's launched the initial velocity of 80 feet per second. We have an angle of 80 degrees to the horizontal. How long? How long? So we're trying to find t. Will it take for the rocket to be 10 feet horizontally from the starting point? And then what's its vertical distance at that point? So we have v, which is 80. We have theta, which is 80 degrees. We actually have our x value, which is going to be 10, because it's 10 feet horizontally. We do not know our time, and we do not know our vertical distance. So we need those two things. Okay, so let's go ahead and use our x equation. So we're going to use 10 equals 80 times cosine of 80 degrees times t, and that all comes from up here. So 10 is my x, my v, this is my theta. Okay, so we need to solve for t. So t is just going to be 10 over 80 times cosine of 80 degrees, which is going to be, well, you need to type that into your handy dandy calculator. That shouldn't be a 2. That should be there's a poorly drawn degree sign. It should be 0.719 seconds. Okay, so that's my t value. Now ask me for my y value. So I'm going to do for my y value is just type this in. So I'm going to get 80 times sine of 80 degrees times the time, which is going to be 0.719. Now, if you're not a student of mine, you probably don't know what that little ... means, okay? Anytime I have a ... that just means I need to plug in the whole value and not just the rounded value, because you'll get an incorrect answer. So your calculator gave you 7 digits, like 0.719, blah, 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 blah. All those digits need to be spoken for when you go through this problem. So you would just go scroll up and just re-pull that number. So that's what that ... means. It means just not the 7 or the 0.719. It's actually all those digits. Plus 1/2 negative 32.719 ... squared. You do that, type it in, you get an answer of 48.374 feet. Okay? So that is our whole notes. If you have any questions, you feel free to email your teacher. You can even leave comments below in the video. That's if I decide to do this on YouTube or not. And that's it.